Hey everyone, I'm Roshan Taneja from Sacred Heart. Welcome to my quick 2-minute tour of object detection and satellite imagery for rainwater unit placement in the Maasai community. I'll share the good, the bad, and the downright hilarious parts of mapping hidden dwellings from space. First off, the project's goal. Identify Maasai dwellings across 500 square miles of unmapped wilderness so we can deploy rainwater harvesting units more efficiently. I couldn't find any existing maps of the community, which led me to create my own using the tools at hand. Here's the magical code, emphasis on magic because debugging it was a mystical experience. I used Python, TensorFlow, and Google Earth Engine, and yes, there were many bugs, like when my model decided every tree was a house. All the gory details are on my GitHub on screen. Challenge number 1, projections. Google Earth Engine uses an oblate spheroid, which is a super precise and super confusing way of mapping the Earth. Meanwhile, based on how I trained it, my CNN model assumed that Earth was just a nice sphere to simplify the math I was doing. I was wrong. I mapped houses to the wrong region, requiring me to do a bit of surface projection, praise this mathematician, to put my coordinates in the right place. Challenge 2, vegetation versus huts. They look almost the same from space. It's like a cosmic game of Where's Waldo. I fixed it by emphasizing ring-shaped structures and using infrared bands because the dead bushes used as boundaries reflect more infrared life than the living bushes around them. Boom, false positives slashed. Here's the fun part. Actual BOMA images and the final map. I clustered the points using k-means clustering algorithm, and we identified clusters F, A, and B as prioritized zones for the solutions. The community placed 108 rainwater harvesting units right before November's rainy season. Next, I'll be integrating hydrological analysis for bigger reservoirs so more communities can benefit. I learned a lot in this process from people all over the world. I think there's a lot more that we can do with remote sensing and machine learning for climate change. So if you want to geek out over spheroid projections or laugh at my frantic commits, head over to my GitHub.